Today we are going to be talking about how we actually go about solving exponential and logarithmic equations. We're also going to continue this into our next lesson because we're not going to cover everything today. So we're going to start by talking about exponential and logarithmic equations. So first, u is equal to v if and only if b to the u is equal to b to the v. Now this property comes in handy particularly when it comes to solving exponential equations when you have the same base. If you're able to rewrite your equations with the same base, it makes it very easy to set the exponents equal to each other. Same with logarithms. So if you are taking the same logarithm on both sides, so that means the same base on both sides, then once you have it set so you have a single logarithm on the left and a single logarithm on the right, then you can use that and say, well, then you can just say u is equal to v. So here's an example. Say you have the equation 8 to the x equals 2 to the x plus 1. So for this problem, if we can, we want to see if we can write it with the same base. So we have 8 to the x and 2 to the x plus 1. We want to look at the 8 and the 2 and see if there's any way for us to rewrite those with the same base. Now 8 is a power of 2, so we can write that as 2 to the third. So this is going to be 2 to the third raised to the x equals 2 to the x plus 1. Now we can write that as simply 2 to the 3x equals 2 to the x plus 1. And now you'll notice we have the same base on both sides. So we can simply say that we can set the exponents equal to each other. So 3x equals x plus 1. So now you can solve for x. So 2x equals 1. And then x equals 1/2. Let's look at the next one. 9 to the x is equal to 3 to the x minus 1. Again, see if you can rewrite those to have the same base. So 9 is 3 squared, so we'll write that. 3 squared to the x equals 3 to the x minus 1. So on the left we have 3 to the 2x equals 3 to the x minus 1. So now we have the same base on both sides, and now we can set the exponents equal to each other. So 2x equals x minus 1, and solve for x. So subtract x from both sides, and we get x is equal to -1. All right, now let's look at an example where we have to use laws of logarithms in order to get a single logarithm on both sides. So see here we have ln of x minus 3 plus ln of 2x plus 1 equals 2 times ln of x. We want to be able to write this so that we have ln of one thing on the left and ln of one thing on the right. Once we have that, we can essentially get rid of the ln's from both sides and just set those equal to each other and solve. So on the left, we have ln of x minus 3 plus ln of 2x plus 1. So to write that as a single logarithm, this would be using the product law, right? So this can be written as ln of x minus 3 in parentheses times 2x plus 1. Now on the right, we do have a single logarithm, but let's try to write it so that we don't have that 2 in front. So instead, we use the power law and move the 2 into the exponent. So we have ln of x squared on the right. Now we have a single logarithm on the left, a single logarithm on the right. They're both ln. So now we can simply say that the x minus 3 times 2x plus 1 has to equal x squared. Okay, from there, now we are just working with a quadratic. It might be a little bit of tedious work, just multiplying everything out, but we have 2x squared plus x minus 6x minus 3 is equal to x squared. Let's move everything over to one side and combine like terms. That gives us x squared minus 5x minus 3 equals 0. And that's a quadratic. You want to see if it's factorable. It doesn't seem factorable, so we'll have to use the quadratic formula. So x is equal to 5 plus or minus the square root of 37 all over 2. All right, let's look at another example like this. We have log of 4x minus 1 equals log of x plus 1 plus log of 2. Again, you need to have a single logarithm on both sides before you can get rid of the logarithms. The left-hand side looks fine. We just need to simplify the right-hand side to be a single logarithm. Since it's the sum of those two logarithms, we can use the product law and write them as the single logarithm of the product of x plus 1 and 2. Now, a single logarithm on both sides. So we can write this as 4x minus 1 equals 2 times x plus 1. Now we'll go ahead and distribute. So we have 4x minus 1 equals 2x plus 2. And then subtract 2x from both sides, add 1 to both sides, so 2x equals 3. Get x by itself, so we have x is equal to 3 halves. Let's look at the next one. We have 2 log of x equals 3 log of 4. We do have a single logarithm on both sides, but we want to get rid of those constants that are out in front. We want to move those into the exponent. So on the left we have log of x squared. On the right we have log of 4 to the third. So we have x squared equals 64. And because we have the single logarithms on both sides, we can just write that x squared equals 4 to the third. Now, be very careful here. Remember that when you take the square root of both sides, we in fact have two answers, right? We have positive 8 and negative 8. So x is equal to plus or minus 8. Now, the only thing is, when you go back to check your answer, you see how x is something you're taking the log of, right? Log of x. Now, there were some restrictions as to what you can take the log of. Remember that you can't take the log of a negative number. So our answer here is actually only x equals positive 8, because you won't be able to take the log of negative 8. So be very careful when you're working with these problems and x is inside of a log function. You want to make sure that when you plug it back in, that you don't end up taking the log of a negative number. On to our next example. We have ln of 6x minus 1 plus ln of x equals 1/2 times ln of 4. So again, our goal here is to get a single logarithm on either side of the equal sign. On the left, we can combine those using the product law. So this will become ln of 6x minus 1 in parentheses times x. And then on the right-hand side, we want to get that 1/2 into the exponent. So this is ln of 4 to the 1/2. Now that we have a single logarithm on either side, we can write this without the logarithms. So 6x minus 1 times x is equal to 4 to the 1/2. Now we can multiply and simplify the right-hand side. So we have 6x squared minus x equals 2. Right? 4 to the 1/2 is the same as square root of 4, which is equal to 2. It's a quadratic that we're solving here, so we'll move everything over to one side and see if it's factorable. In this case, this is in fact factorable, so this will be 2x plus 1 and 3x minus 2, which equals 0. And then we can set each factor equal to 0 and solve, so we have negative 1/2 and 2/3. Now again, remember, we're not done yet. We still need to go back and see if either of these answers will end up making us take the log of a negative number in the original equation. So if we look at what we have here, we have -1/2 as an answer. If you plug that into ln of 6x minus 1, you'll end up with ln of -3 minus 1, which is ln of -4. So that forces us to take the ln of a negative number. So our only answer here is x equals 2/3. Okay, so the next thing we're going to talk about is how do you solve equations when you're working with different bases. So when you have something that can be written with the same base, so for example, if you had the 8 and the 2, you could write the 8 as 2 to the third, and then you're able to work with that and get the exponents equal to each other. But that's not always going to be the case. When that's not the case, these are the 3 steps that you'll use to solve the equation. So the first step is to take the log of both sides. Second, use the power law to move x out of the exponent. And then once you've done that, you can solve for x. So let's do an example of this. We have 5 to the x equals 2. You can see very clearly here that there's no way for us to write 5 as 2 to a power or 2 as 5 to a power. So what we're going to do is we are going to, step 1, take the log of both sides. Now it's up to you if you want to use common law or natural law or any other type of log. I like to use natural log, but it really doesn't matter. Now generally, you will end up using a calculator at the end, so natural log and common log are good ones to use. Otherwise, you'll end up trying to take the log base 7, for example, and that will be a little bit harder to access on your calculator. Okay, so that's the first step. The second step is to use the power law to move the x out of the exponent. So the x is in the exponent. We're going to use the power law to bring it out in front. So this becomes x times ln of 5 equals ln of 2. And then now we try to get x by itself. So to get x by itself here, we divide by ln of 5. So our answer is ln of 2 divided by ln of 5. Now depending on the problem, you might be asked to find an exact answer. If you're asked to find an exact answer, you can leave your answer as ln of 2 over ln of 5. If you're asked to find an approximate answer, then you'll want to bring out the calculator and then go ahead and put that in. So we have ln of 2. You want to make sure that you put the end parentheses in there before you divide. And that comes out to be about 0.4307. Let's do another example. So we have 6 to the x is equal to 3. Take those 3 steps again. So first step, take the log of both sides. Ln of 6 to the x equals ln of 3. Second step, use the power law, bring the x out in front. So we have x ln of 6 equals ln of 3. And then divide both sides by ln of 6. Plugging that into the calculator, this comes out to be about 0.6131. Alright, now let's do a more complex problem. 4 to the 3x minus 1 is equal to 3 to the x minus 2. We're going to follow the same steps. So first, you take the log of both sides. So we have ln of 4 to the 3x minus 1 equals ln of 3 to the x minus 2. Use the power law to bring the exponents out in front. Now here's the important thing here. In this step, we are going to make sure, because the exponents are not just x, but a longer expression with multiple terms, we're going to make sure to put that in parentheses when we bring it out in front. So this is 3x minus 1 in parentheses ln of 4 equals x minus 2 in parentheses times ln of 3. Now we can distribute ln of 4 to the 3x and ln of 4 to the minus 1 and do the same thing with the ln of 3. This gives us 3x ln of 4 minus ln of 4 equals x ln of 3 minus 2 ln of 3. Now we need to get x by itself. You'll notice this is more complicated than the last problem. And what we need to do, or one of the strategies that you can use, is you can get all the terms that have an x over to one side and all the terms that don't have x over to the other side. So here I'm going to move the ln of 4 over to the right-hand side and the x ln of 3 over to the left-hand side. So I've gathered all the x terms together on the left. When you do that, you're able to get the x by itself. How? Because in the next step, what we're going to do is we are going to factor out the x. So if we factor out the x, we're left with 3 ln of 4 minus ln of 3 in parentheses. On the right-hand side, we have ln of 4 minus 2 ln of 3. And now to get x completely by itself, we just divide both sides by what's in parentheses. Again, when you put this into your calculator, this is going to be a little bit more complicated, but you just want to make sure that you put parentheses around the numerator and parentheses around the denominator. So we'll start with parentheses, then ln 4 minus 2 ln 3, I close the parentheses on the numerator before I divide. And now in the denominator, I will again put this entire thing in parentheses. Hit enter. And our answer comes out to be about negative 0.265 or so. Okay, we have one last example. E to the negative 3x equals 2. So we'll again stick with the same 3 steps, so start by taking the log of both sides. We'll use the power law and move the negative 3x out in front of ln of e. So now we have negative 3x ln of e equals ln of 2. Now, there is something we can simplify here before we start solving for x. Remember, ln of e is equal to what? Well, e to what power gives you e? E to the first power gives you e. So ln of e can be simplified to 1. That means this is just simply negative 3x equals ln of 2. Now let's solve for x. So x is equal to ln of 2 divided by negative 3. And again, just be very careful when you put it into the calculator and make sure you are accounting for all the parentheses. And it looks like our answer comes out to be about negative 0.231.